Okay. Hello, everyone. So today we're going to discuss geometric sequences and series. So this is another type of sequence and series wherein the sequence is being multiplied to get to the next number. Remember that. Okay. So let's start by defining what geometric sequence is. So geometric sequence is basically the ratio of any term to the previous term is always constant. So which means if you do the opposite way, divide it back, the number is always the same. Okay? And that number, or the number that's being multiplied or being divided, is what you call the common ratio. Okay? So the common ratio by definition is the constant ratio in a geometric sequence, or it's the numbers. Okay? So like this one, okay, which of the following, okay, is a geometric sequence? Is it the one on the left or on the one on the right? Okay, so looking at this, notice that in the one on your left, to get to 12, 6 is being multiplied to 2. So it should be that the 2 is the common ratio. But if I multiply 12 by 2, it doesn't give me 24, but it doesn't give me 24, but it gives me 20 here. So this one on the left is not a geometric sequence. However, on the right, okay, if I multiply, so this one is getting smaller, okay, so if I multiply this by 1/4, so if I multiply 256 by 1/4, or if I divide it by 4, okay, I get 64. Divided by 4 is 16, divided by 4 is 4, divided by 4 is 1. But here, the constant or the common ratio is 1/4. That's the number that is being multiplied. So here, the one on the right is a geometric sequence. Okay? Clear? Let's go on to the next slide. Okay? So what we're going to do is to derive the formula. So let the first term, a sub 1, be a sub 1. Remember, to get to a sub 2, we may multiply a sub 1 by a number, right? Let's call it a sub 1 times r. Okay? Now, to go to a sub 3, I have to multiply a sub 2 by r. But a sub 2 is the one in red, so I'm just multiplying. So I get a1 times r, so I get a1 r squared. Okay? Take note of the pattern. This is squared, this is 3. What do you think 4 would be? 4 would be a3 times r, but a3 is the one in here. a1 r squared. So r squared times r, that gives you a1 r to the third. Okay, so when it's a4, it's r to the third. So which means when it's a5, it's r to the fourth. So generally, okay, to find the nth term of a geometric sequence, that's going to give you a sub n equals a sub 1 r raised to the n minus 1. Okay, that's the formula. Okay, so notice this is in your textbook, okay, with an example. So the nth term of a geometric sequence with the first term 2 and a common ratio of 3 is given by 2 times 3 raised to the n minus 1. So first term, a sub 1 is 2, r is 3. Okay, now let's work for this following examples. So write the nth rule, or write the rule for the nth term of each sequence, and then find a sub 8. Okay, then I'm going to ask you to do this on your own. I'm going to wait. Okay, so for this, notice a sub 1 is 5, right? R is 3, that's the number that's being multiplied, right? So the equation is 5 times 3 raised to the n minus 1. And then I'm just going to find a sub 8 by subtracting n as 8. So 8 minus 1, that gives you 7. Use the calculator to do this. You have 10,935. Okay? And this is B. Notice it getting smaller and smaller, and then there's alternating signs. So 88 divided by 4, or divided by 2 is 44, or negative 2. But you're multiplying this by 1/2. So that's the reason why you get 88, first term. R would be negative 1/2 raised to the n minus 1. And then substitute 8 as 7. You get 0.6875. Okay? Now, suppose you're supposed to find a sub n, just given a term, not a sub 1, and a common ratio. Okay, so you're given any term, and then you're given a common ratio r. Let's have an example. So one term of a geometric sequence is a sub 4 equal to 12, and the common ratio is 2. So we're going to find the explicit rule a sub n and n a sub 10. Okay? So first, we need to come up with the formula that is whatever we have. So n equals 4 because a sub 4 is 12. And then a sub 4 is 12, so it's automatically, so n is 4. And the common ratio is 2. Substitute that into the formula. So which means a sub 4 is equal to a sub 1 times 2, because that's your common ratio, raised to the 4 minus 1. So a sub 4 is 12, right? And then 4 minus 1 is 3, 2 to the third is 8. So 12 equals a sub 1 times 8. And then I'm going to solve, which means if I divide both sides by 8, my a sub 1 is 12 over 8, or simply 1.5. So my equation now will be 1.5, which is my a1, okay, times 2 raised to the n minus 1. Okay? What if you're having two terms? Okay? So if I have two terms, example, two terms of a geometric sequence is a2 equal to 12 and a5 equal to negative 768. Now write the explicit rule for an n term of a sub n. So you're looking for an. So basically we're going to use the formula here, that one, okay, which is a sub n equals a sub 1 r raised to the n minus 1. So substitute for 12. So 12 is the first term, right? So it's 12 equals a1 r to the 2 minus 1. The 2 here because it's the second term right there. Okay? Which means I get now, simplify, a sub 1 r2 minus 1 is 1. So it's going to be a1r. Now for the fifth power, for the fifth term, a to the 5, it's going to be negative 768 here equals a1 r raised to the n minus 1. Our n is 5, so it's 5 minus 1. So it's negative 768 equals a1 r to the 4th. So we're going to solve this simultaneously. So if I'm going to do that, I'm going to substitute a1 in here, solve here, by dividing both sides by r. So the first one, my first equation, if I divide this by r, I get 12 divided by r, which is equal to a1. And I'm going to plug that a1 to the a1 of the second equation. That's why I have negative 768 equals 12 over r times r to the 4th. Okay? So the r here and one of the r's in r to the 4th cancels out. So I'm left with 12r to the 3rd. Okay? Now since I'm solving for r, I need to divide both sides by 12. So if I divide this by 12, so 768 negative divided by 12 is negative 64. And negative 64 equals to r to the 3rd power. If I get the cube root, r equals 4. So I have now my r equals 4. To find a1, I got to substitute this to the r right there. So 12 divided by 4, okay, that gives me a1 equals negative 3. Okay, so the explicit rule will have the first term to be negative 3 and r equals negative 4. So the equation is negative 3 times negative 4 raised to the n minus 1. Okay, now let's try to apply this one in word problems. Okay, let's go to the sum first. Okay, so this is just simply the derivation. So the formula doesn't simply just come from nowhere. Okay, so the sum of the n terms would be a sub 1 plus a sub 2, which is a sub 1 times r, a sub 1 r squared, a sub 1 r cubed, and so on until a sub 1 r to the n minus 1, because that's the last term, right? So first and the last term. Now, what I'm going to do is to multiply everything by negative r. So if I multiply this by negative r, the top one, so that's going to be negative a1r, which is already this, because I'm multiplying the top one by negative r. So negative ar1, negative ar2, and so on. And then I'm going to multiply the last one, okay? A to the 1, r to the n minus 1, okay? Times a1, r to the n. Now, if I simplify that and combine, I get now this. Everything cancels out. This cancels out, this cancels out, this cancels out, this cancels out, okay? Until the very last term cancels out, and then the last term right there. Okay? So, if I multiply that, I can factor s sub n. So, factor s sub n, it's going to be 1 minus r, and then I factor a sub 1 here. 1 minus r raised to the n. Since I'm solving for s sub n, divide both sides by 1 minus r. So this is what the formula is. A sub 1 times the quantity 1 minus r to the n over 1 minus r. Okay? This is the one under our textbook. Okay? So like say, how do you find the sum of the series below? Okay. What's a sub 1 here? A sub 1 here is? Okay, try to look. It's the summation of 4 times 3 raised to the k minus 1 from 1 to 10. So first 10 terms, right? So here, what is a sub 1? A sub 1 is 4 and r is what? 3. So all you got to do is just substitute that to the formula here. Okay, so r is 4, okay, and r is 3. Then plug it in the formula. So notice that I simply plug this in. 1 minus r raised to the 10 over 1 minus r. Plug in a sub 1, and then you're going to use the calculator. Okay? Okay, let's have an example. So solving a real life problem. So you can calculate the monthly payment, M, in dollars for a loan using the following formula. Okay? So M equals L over the summation of 1 over 1 plus I raised to the k from k equals to 1 to t, where L is the loan amount in dollars, I is the monthly interest rate in decimal form, and t is the term in months. So calculate the monthly payment on a 5-year loan with for $20,000 with an annual interest of 6%. So here you're borrowing $20,000, okay, and the interest rate is 6%. And then the question is, how much do you pay monthly? Okay, and then you're going to be paying it in 5 years. So in monthly terms, since 12 months is 1 year, multiply 5 by 12, you get 60. So that's your T. Okay, so since it's annual interest rate of 6%, so 0.06, I have to divide it by 12 because it's annual. So the monthly interest rate is 0.05, and L is 20,000. So all I got to do is just simply plug those values in, okay, to the formula. Okay, now the question is, how do you compute this? You need to compute the ones in the denominator, okay? So notice this was all obtained by substituting all these numbers in there. So notice that the denominator is a geometric series. What's the first term? Would now be 1 over 1.005, okay? With r also with 1 times 1.005, because it's add this raised to the k, so it's just simply multiplying k again and again. So use the calculator, you'll get 386.66 cents, or $386.66. Okay? So our homework is on Delta Math. but we're gonna do this. The date is different, but it's supposed to be um, assignment is on there. Okay, so that's the lesson for today.